polynomial function of degree n is a function of the form p of x equals anx to the n plus an minus 1 x to the n minus 1, and so on, plus a1x plus a0. N is a non-negative integer called the degree, and an is always non-zero. The numbers an minus 1, and so on to a0 are called the coefficients, where a0 is called the constant term, an is the leading coefficient, and the term anx to the n is called the leading term. For example, the polynomial p of x equals negative 2x cubed minus 9x plus 7 has degree 3, has a leading coefficient of negative 2, and has a constant term of 7. The simplest functions to graph are monomials, polynomial functions of the form p of x equals x to the power of n. Here are the standard polynomial functions and their graphs. It is useful to have these memorized. We can always determine the quadrants a graph starts and ends in, called the end behavior of a graph, based on the degree n and the sign of the leading coefficient of the polynomial. When the degree is odd, if the leading coefficient is positive, then the graph starts in quadrant 3, maybe crosses the axis a few times in the middle, which we're not really concerned about since we just want to know about the quadrants that the graph starts and ends in. So there is something going on in the middle, but the point is that it starts in quadrant 3 and then eventually it goes up into quadrant 1. Now when n is odd and the leading coefficient is negative, the graph starts in quadrant 2 and ends in quadrant 4. For the case when n is even, if the leading coefficient is positive, then the graph starts in quadrant 2 and ends in quadrant 1. Finally, when the leading coefficient is negative, the graph starts in quadrant 3, does some stuff in the middle, and ends in quadrant 4. Now, a lot of polynomials of degree greater than 2 are often not very useful as models. Consider the following example of a local pesticide company that can produce up to 50 liters of a certain chemical each day. The daily cost C of production is estimated to be C equals negative 0.002 q cubed minus 0.02 q squared plus 6q plus 130 on the domain from 0 to 50. We want to determine the fixed and variable costs of production. Then we want to compute and interpret C of 0 and C of 50. So C of 0 just means we evaluate the cost function at q equals 0. When we do this, we get $130. So this means that when the company produces nothing, it still has $130 to pay, which are the fixed costs. When q is 50, C of 50 is 130. That means that when 50 liters are produced, the total cost is 130. We can conclude from this that this is not a realistic model since costs should increase as the quantity produced increases.